Hello, and welcome to another edition of Lab Rats. My name is Andy Walker.
I've got a bad feeling about this. He's waving around the cheese. I'm Sean Carruthers.
And this is cheese. Yes, it is. It's cheese.
Oh,
and
that's disgusting. Have you been leaving that out under the sun all day?
It's kind of floppy and sweaty.
Cheddar should not wiggle like that.
Cheddar is a great medium, though, to work in when you want to demonstrate how technology works.
If I recall correctly, sir, you have used cheddar to describe how the flow inside a transistor works.
Yes, and also, no, I guess that's the only time I've used cheese before.
Well,
I like to use, foodstuffs to explain complicated things.
We're about to use cheese to explain what exactly here?
Perpendicular storage technology. So we have hard drives, right? We have hard drives, and over the years, they've been getting bigger and bigger. Well,
yes.
Hitachi has invented a new technology called perpendicular storage to put more and more data on a magnetic disk. And I'm going to show you how it works. Well, we are, him and me, using cheese.
You're actually going to show us how it works. This is a food demo. We don't really learn much from these.
Yes, we do. It's very, very informative and very, fun because it's cheesy.
It's very cheesy.
All right, we'll be back after. What's that?
That's the train. It's carrying cheese into the downtown.
That's right. To replenish the supply that we've purchased.
Yeah, you got a lot of cheese on the table. I think there's a shortage.
Cheese here. Anyway, we'll be right back after this message with a food demo on how perpendicular storage works. But you can't wait.
I can't.
This is a pair of sneakers. They're worn and comfy. This is a Jack Russell Terrier. It likes shoes. This is Camtasia Studio 4. It can edit your screencasts. Now answer our trivia question. What screencast editor can be left unsupervised and doesn't smell like feet? I'll be back at the end of the show with the answer.
Okay, so I'm going to show you, it's true, I'm going to show you how...
Hold on a second. Did someone just cut the cheese? You know I had to say that.
No, I'm just cutting the cheese over here, yeah. But I am physically cutting the cheese. Okay, so to understand how perpendicular storage technology works, you have to understand how magnetic storage works. First off, traditional hard drives, right? So I've taken some cheese and a pizza dough here, and I've shown you how a traditional magnetic hard disk works. Now it's going to fall apart here, but let me get here into the other camera. So as you can see, there are little flat pieces of like a magnetic material on the hard drive, and it kind of goes around in a concentric circle, right? Like that, see?
This is not exactly to scale, of course.
Not exactly to scale, no, but the idea is there's a bit, right? For every bit, what you do is you take a magnetic reader. I've got a lighter here. See, you got a lighter? And what happens is the polarity on the magnetic region gets changed. So, on one end is negative, and the other end is positive, right?
Okay.
But it's actually a horizontal shape, right? It's flat, like this on the actual disk, right? See, like that. And then when the polarity changes, it changes so the negative is on one side and positive on the other
direction. Okay, I can understand that.
So understand that, right? The
so
problem
you use
is
a lighter to change your cheese in the other direction.
Sort of, kind of. You use a right head to change the magnetic polarity on the surface of the disk.
Okay, so this lighter is our right head.
That's right.
I'm just glad this wasn't a blowtorch, because this could have gotten
I wanted to use a blowtorch, and they wouldn't let me. Oh, well. Lighters it is. I guess
the last thing we need is like a river of cheese flowing through our floorboards into the apartment below.
But are you following me so far?
I'm following you so far.
This makes sense, right?
This does make sense.
So the way that they would fit more information onto a disk was by taking the area of the magnetic area and reducing it in size, right?
Making it smaller. So smaller cheese means more data.
Right, like that. So hold that. So that's a smaller, so of course now we could change the polarity, right?
Ah! Jeez.
So, and therein lies the problem. In fact, if we cut it even smaller, and we get them to hold it, and we change the polarity, watch what happens.
Actually, give me the lighter this time. I don't always want to be the guy that gets burned.
This is what's called superparamagnetic.
Okay.
What happens is this, is the right head comes in contact, and it's very hot.
Yes.
So what's happening here, what I'm demonstrating here, is the idea that when you get small areas on a disk, what can happen is the polarity can change spontaneously, not just because there's been a right head over it, but based on temperature as well.
Right.
And so what happens is you have a highly dense disk, but just a change in temperature can ruin the magnetic polarity, and therefore ones and zeros, data can get lost.
Yeah, bits can start flipping spontaneously
Just because of temperature. Right.
Because of the temperature, they're next to another one.
So since you can't put any more cheese on the disk, or can't put any more magnetic area on the disk, what happens is you're stuck with that amount of storage on that particular disk.
Can I interrupt this little description right here to say that you got cheese fingers?
Yes. My fingers are cheesy. Nice, huh? Anyway, okay, so now we're moving on to perpendicular storage.
Perpendicular storage.
So back in the day, now you tell me this was like years ago.
Yeah, apparently, well, let's explain what it is first,
Okay.
and then we'll explain when that happened.
So in order to get more data onto the surface of the disk, which remains the same size, you have to create a smaller area.
Right.
So what they decided to do, what Hitachi decided to do, was instead of putting the area lengthwise so that it was flat on the disk, what they do, they just stand it up on end. So let me demonstrate that. Yeah, this is large scale now, okay? So let's, in the old style, there'd be like, let's go down to this camera here, there'd be two areas on the disk flat, side by side like that.
Okay, now
right?
that's a lot of space taken up by your cheese.
That's exactly, it's a lot of space. But what happens if you take these particular pieces and you put them up on their side like this?
Oh, that takes up the same amount of space overall, but you get more of them in this direction.
In that direction there, exactly. So, but in order to do that, what you have to do, can you pass me some, no, not that, this one
Let's
here.
move this off to the side so we
Open
don't
that
get cheese in your drive.
Pizza crust. So what happens is you actually have to, it's not working. Oh, there we go. So what I'm going to do here is I'm actually going to make the crust bigger. There we go. Thank you very much. So what's important here is that...
this is disgusting.
Isn't it great? So this is actually the material the disc is made out of. So give me that. Hey, easy, easy. So the idea here is to actually make the disc that the bits sit on thicker, right?
Okay.
So what you're doing, you're going to plant the vertical pieces. You can hold that for me?
Yeah, put this down out here so we can actually see it over there.
All right.
Okay, so that's nice and
Let's
big.
move it up forward here. All right. Thank you. So notice it's thicker than this one here over here, which is really thin. And we're going to put our cheese vertically onto the surface. Now the reason we do that is when there's a circuit made, when the lighter comes along, right, and it actually changes the polarity, what happens is there's a circuit is made, wink, and so that flips over.
around.
But the energy actually runs into this thicker area here and back to the right head, so you actually get a circuit coming through. And we'll show an animation at the end that kind of shows exactly how that works. But that's how perpendicular technology works. Now it has an areal density, an increased density of, what did you say? Oh, I think you did some research on this, right? It was
I took a look at this. It was a lot. It's theoretically up to 1 terabit per square inch.
Terabyte.
Terabit.
Per square inch.
But that's
of disk.
a lot of data because you've got several square inches inside a typical hard drive platter. So you could see one of these things, with a few platters inside there being like easily half a petabyte.
Wow.
Just using standard, perpendicular storage technology.
So what's cool about this is that last year, back in 2006, Hitachi introduced an actual perpendicular storage device. In fact, and this is actually a Seagate disk now that I bought a few weeks ago. This cost me, I think it was $200. Hey, no cheese on the hard drive. A couple $100 for half a terabyte of space using perpendicular technology. Seagate 7200.10 is what the model number is. But it exists today, and moving forward, of course, we're going to have disks for computers that take they're stored terabytes and terabytes and terabytes a day.
Exactly. So we're up to a terabyte in them now, thanks to perpendicular storage.
In 2007.
In 2007.
Right.
And, going forward, maybe by the end of the year, it'll be 2 terabytes. But, yeah, the theoretical, if we can hit that maximum level that I think Fujitsu is looking at 1 terabit per square inch, you can just imagine like half a petabyte just within the same size.
Right.
Not bad at all. Now, the one thing I did notice is that this actual technology, in theory, has been around for a number of years. I think it was 1976 that someone first said, hey, this would be a really good idea to be able to do this, stand it on end
cheese
instead.
technology instead of horizontal cheese technology.
But it took about 30 years for it to be made into practice, for it to actually work and to be feasible. I mean, back in '76, they didn't have the kinds of hard drives we even have now, so it wasn't even an option there. So
Right.
it was a concept, and now it's been applied
it's real.
to hard drive technology.
Wow. Isn't that fun?
That is pretty fun.
Now, we're going to put a URL right here that points to a really great Flash video that Hitachi created to really give you sort of a sense of how it all works. It's got a fun little tune and some animated characters, but it'll show you.
I'm just a bill up on... Wait, this is the wrong animation.
But it's very similar.
Yes.
Anyway, but check that out because that's a lot of fun. And when I found that, I thought, wow, that's something we should share with you guys after we show you how the cheese works. All right, let's take a look at another message from one of our sponsors, and we'll be right back after this with, more food demos and cheese things.
Earlier in the show, we asked you what screencast editor can be left unsupervised and doesn't smell like feet. Is it A, a pair of sneakers, B, a Jack Russell Terrier, or C, Camtasia Studio 4? The answer is Camtasia Studio 4. Learn more at labrats.techsmith.com.
Now, I gotta say, every time I do a food demo, Sean rushes around, with a mop, and he's cleaning, he's running over getting dough and that sort of thing. So,
Yeah, it's a little bit different when it's my own place. When we do something like this over at the lab or the old Call for Help studios...
I get worse drama from there. They run around to chase me with like fire extinguishers and stuff.
It's true. Well, people that know you and your food demos may have remembered the one demo where Leo blew up a bag of icing sugar all over the entire studio.
Including the $60,000 cameras.
Several of them, yeah. And that took like all of our lunch hour to clean up. So we're waiting for that day to happen again. So we know what you're capable of. Even though you didn't blow up the bag of icing sugar.
People love them.
You were the catalyst, yes.
I know. Anyway, we hope you enjoyed the food demo today. We always want to get your feedback, so send it to feedback@labrats.tv.
Mm-hmm. If you have any particular show ideas, you can send them there.
Food demos. I always need food demo ideas.
Food demo ideas.
If you want me to work in a particular medium and you want a particular concept demonstrated, then I'd be happy to do that.
I would like you to use mashed potatoes and jam to explain the concept of CRT monitors.
There you go. Actually, for that, I want to actually use a turkey out of a cannon.
A turkey out of a cannon.
One day I've been threatening to do that on the lab. So
not in this apartment.
No, we'll have to use a miniature cannon.
Maybe and a miniature turkey. No. Oh, interesting story.
Yes.
Apparently, a cat, when it's going through the X-ray
at
an airport, looks a little bit like a turkey.
Oh, I don't even know how you know that.
No, someone's cat once crawled into their luggage and went to sleep inside the luggage, and when it was checked through and went through the X-ray, the person's like, "Did you check a turkey into your baggage?" And you're like, No, I didn't.
It's a cat.
And on the other side, the cat crawled out a little bit upset that it had gone through the check-in process.
Did it survive?
But it crawled out. Oh, it survived just fine.
Oh, good.
But it crawled out, went to sleep again, outside the suitcase. Anyways.
All right, well, thank you for downloading today. Don't forget to check out our forums at labrats.tv with the link. Click on the forums. It's shared at cyberwalker.com. And cyberwalker.com is my tech advice site, so if you want to check it out, we have hundreds and hundreds of articles on how to do all kinds of really cool things with your computer.
Yeah, and the forums, like I said, they are shared with cyberwalker.com and Labrats, so you can talk to other Labrats fans, and you can actually go into the other forums and get some advice on how to fix up your computer.
Yes.
So,
all right. Well, that's it for today's episode.
It is.
I'd like to give you some dough. Oh, you got it.
Good save.
All right, that's it from us. My name is Andy Walker.
I'm John Carruthers.
We'll see you next time.
Are you ready? Try this at home.
Hello, I'm Cheesy McCheesehead. I want to encourage you all to watch another episode of Lab Rats, where we talk about perpendicular storage technology. Yeah!